how do our channel intros normally go?
Okay, it's something like good morning, buenos dias, привет.
I don't think that's right.
Okay, I'll be honest with you, Frank. My memory has not really been on point lately.
What a coincidence. Because today we're going to be adumbrating the first half of Unit 7A in Meyer's Psychology for AP textbook, Memory. Let's get to it. All right, Abe, start us off.
Let's do it. First, here's a sentence that I'll ask you about later in the video, but you probably won't remember it correctly. The intelligent Frank reads books in the library. We'll go over that later. Anyways, memory is learning that lasts over time, and it's also information that has been stored in your brain and can be retrieved. Now, memory functions similarly to how a computer functions, in that it involves encoding, which is getting information into our brain, storage, which is saving that information, and retrieval, which is being able to extract it from our brains. Now, let's talk about how to model memory. We have the theory of connectionism, that memories derive from intertwined neural networks. So if there's a certain activation pattern, a specific memory is triggered. Psychologists Atkinson and Shiffrin believe that we form memory in 3 steps. First, information is recorded very briefly as sensory memory. Second, the information processes into our short-term memory where it is encoded. Short-term memory can hold a few pieces of information briefly, such as the digits of a phone number while you call. Frank, try this. Third, the information goes into our long-term memory, from where it can later be retrieved. Note that long-term memory is relatively permanent and is also limitless. So some information will go directly into our long-term memory, meaning that it skips the first 2 stages of Atkinson and Shiffrin's model. The concept of working memory involves focusing on the important stimuli bombarding our senses. Our senses are constantly being overloaded, so we have a tendency to zoom into what our brains deem the most important. The important stimuli are processed alongside information retrieved from our long-term memory. Thus, working memory develops connections between old and new information and allows us to solve problems. All right, Frank, can you give me more detail on how working memory functions?
I'd love to. We have to dedicate varying amounts of mental power to remember certain events. Some events are easy to remember, such as space, time, and frequency. These are remembered through automatic processing, or encoding of information that happens subconsciously. At the other end of the spectrum lies effortful processing, or memories that take conscious effort to dredge up, but tend to last much longer. You know that the US nuked Nagasaki and Hiroshima to end World War II because at one point you actively studied to remember it, and will likely be able to recall this information for years. You know that you had a Chipotle burrito for dinner last night due to automatic processing, but will likely not remember this in a few weeks. Now for a handful of study tips. The first, and unsurprisingly, when we do something a lot or rehearse something, we remember it far better. When Abe gets in his car, he hits the brake, turns the key, drops the parking brake, and puts the car into gear in one swift movement because he does it every day. Another study tip could be this so-called spacing effect. We remember things drastically better if we learn them over a period of time. That's why it's better to read a textbook section by section than all the night before. Finally, the serial positioning effect, which states that we remember the first and last items in a list. This is why, when students guess on tests, they are more likely to pick A or D than C or B. Abe, how do we process information?
Well, Frank, you hit the nail on the head there. The key idea here, to quote the book, is that we process information by encoding its meaning, encoding its image, or mentally organizing it. So we encode meaning for verbal information. Remember the sentence I gave you guys about Frank at the beginning of this video? Can you repeat it word for word? You might recall it as the intelligent Frank reads his book at the library instead of in the library, since you remember what you encoded, which was the meaning of the sentence and not the literal text. This is what I mean when I say when we process verbal information, we encode its meaning. So here's some vocab in this section. For visual encoding, it tells us that we visually encode images. Acoustic encoding tells us that we acoustically encode sounds. And semantic encoding tells us that we semantically encode meaning. Now, which type of encoding is the best for remembering something? Since visual and acoustic encoding involves processing at a shallower level, semantic encoding tends to be the most effective.
Epitome aperu fer diera de mudi fabrica. Epitomo peri de fer de fabrica?
Not quite, Frank. The fact that semantic encoding is the most effective for memory is the reason why it would be much easier for both you and I to memorize a speech in English rather than in a foreign language, such as Latin. When the speech is in English, we can understand its meaning and then semantically process it, cementing it into our memory. Now here's another study tip for you guys. The amount you remember depends on the time spent learning and on your making it meaningful. Study hard. Let's zoom into visual encoding. Visual imagery or mental pictures aid our memory. For example, it would be easier to remember a concrete word like cigarette since you can visualize it. And it would be harder to remember a more abstract word that can't really be visualized, like the word inherent. Basically, with concrete words, we can encode them both visually and semantically and cement them into our memory further. Mnemonics, or memory aids, function based on imagery. PEMDAS is a mnemonic that many of us probably learned in our pre-algebra class while studying the order of operations, and it's listed on the side of this slide. Now, Frank, how does the brain encode more complex information?
Good question, Abe. As the brain has to deal with so much information, it has a few tactics to fight against really complex and really lots of information. One of the main ways is through chunking, or organizing information into familiar units such as words or images. An example would be a cell phone number, how everyone says their cell phone number in a pre-existing order of 3 numbers, 4 numbers, instead of just a massive gob of 10 numbers. By chunking it together, it's easier to remember and easier to say. More complicated are hierarchies, which further subdivide information that has already been encoded through chunking. Hierarchies allow you to group information together in order to recall it more efficiently. When we learn about the battles of the Civil War and World War I and World War II, we're using hierarchies to place them in the appropriate war. So when you think about Verdun, you don't immediately also think about D-Day or some battle in the Civil War. You think about other World War I battles because you've chunked them all together within the hierarchy of wars and battles. Abe, tell me about some of our memory superpowers.
Ooh, let's get into it. We're going to discuss 2 interesting types of memories here. The first is iconic memory, and that's like a short-lived photographic memory that allows us to recall an image with near-perfect accuracy for a fraction of a second. And you can see iconic memory being demonstrated in this picture. The second type of memory is echoic memory, which is similar to iconic memory, except it's for auditory stimuli instead. So iconic is for visual stimuli, while echoic is for auditory stimuli. Echoic memory allows us to recall sounds or words for a few seconds after we hear them. And again, you can see echoic memory demonstrated in this picture. Now, the key thing to remember here is that we can only consciously process small amounts of information in a given moment. So to put this into different words, short-term memory has a limited life and a limited capacity. Regarding the limited life, let's say I show Frank a list of letters and ask him to recite them for me. Also assume I prevent him from rehearsing. First, I ask Frank to recite 3 seconds after I show him the letters, and he remembers about half of them. Then I ask him to recite 12 seconds after I show him the letters. At this point, he may scarcely remember any of the letters. Short-term memory thus has a limited life. Regarding capacity, we can usually only short-term remember around 7 bits of information. So remembering a phone number, which typically has 10 numbers or 10 bits of information, is very difficult for most people. Now, I also have one note regarding long-term memory. Studies have proven that our capacity for storing long-term memories is basically infinite. We will not reach a point when, every time we memorize something new, we forget one of our older memories. Capacity is infinite. All right, Frank, psychology is a science, so how about you get into some detail about the nitty-gritties going on in our brains?
Nothing would make me happier, Abe. All right, let's talk about storing memories in the brain. Feels like we've gone a long time without talking about some real hard science, so let's get back to that. Memories are stored through the process of synapses in the brain. If you need a reminder on synapses, look at our past videos, but essentially, memory and learning are thought to occur when synapses increase in firing potential after rapid stimulation, and that's seen on that picture in the left. Pretty basic. You have your initial state where there aren't that many transmitters, then after repeated stimulation, you have a lot more. And that's essentially what memory is. Long-term potentiation, or LTP, and it's just the strengthening of certain neural networks after intense use. Memories encoded through LTP are pretty hard to get rid of, but you can lose recent memories through electric shocks or a blow to the back of the head. Other events that can affect memories are fear and stress, which can sear events into our mind. This occurs because the amygdala, the brain's processor of emotions, directs more fuel in the form of proteins to the brain's memory-forming areas. This is why our parents can all recall exactly where they were during 9/11, and Abe remembers exactly where he was when he got his first and only B. These are examples of flashbulb memories, or vibrant memories of emotional significance. When you look at this beautiful GIF on the right, these three individuals will certainly remember the day that they all were almost killed in a car crash. Lucky them. Abe, I just said that we can only lose memories that are recent, but is that always the case?
Not quite, Frank. The condition of amnesia is characterized by a loss of memory, but people with amnesia can still learn. Though they have no conscious recollection of learning anything, people with amnesia still have an unconscious capacity for learning. Their implicit memory functions, but not their explicit memory. Their implicit memory is their ability to learn how to do something, while their explicit memory is their ability to declare that they know what they have learned. For example, let's say Frank has amnesia. Now, Frank, I really want you to remember what I'm going to tell you right now. Okay?
Yeah.
This is the bathroom.
Okay.
Now, Frank, where is the bathroom?
I don't know, man. You tell me.
Okay, but where do you go when you have to go pee?
Oh, that's easy.
Good.
Right here. I wish you'd been more straightforward about it.
Okay, whoa, Frank, keep your pants on, Jesus. So Frank demonstrated that his explicit memory was not functioning, since he couldn't tell me where the bathroom was right after I told him. But his implicit memory was still functioning, because he demonstrated that he knew where the bathroom was, because he knew where to go when he had to pee. Let's return to the nitty-gritties of the brain. The hippocampus serves to process explicit memories, such as names and events, for storage. Damaging your left hippocampus will affect your ability to remember verbal information, while damage to your right hippocampus will affect your ability to remember visual information. The hippocampus serves as sort of a loading dock, in that memories aren't stored permanently in the hippocampus. Rather, the hippocampus temporarily holds details of a memory before they migrate for storage into other parts of the brain. So while the hippocampus is essential for storing explicit memories, the cerebellum is essential for storing implicit memories. So, if Frank's cerebellum is damaged and I sound a bell and then clap in his face, he might never learn to scrunch his face in anticipation of my clap as a normal person would. The damaged cerebellum will inhibit him from developing conditioned reflexes. Now, Frank, we've talked a lot about how information gets into the brain, but how does it come out?
Well, Abe, let's talk about retrieval, or the idea of getting information out of the mind. Here we have a few main vocab terms. The first is recall. To remember things is simply to recall them, or retrieve information. Recall can be measured through recognition, generally through a multiple choice test. Another measure of memory can be found in relearning, or the difference between learning something for the first time and learning it for the second time. So if when you're 16, your father teaches you how to drive a manual car, and then you don't drive a manual car until you're 28, you'll probably still be able to learn how to drive it quicker the second time, and that's because of relearning. And finally, memory can be influenced through priming, or the unconscious planting of an idea or activation of a memory. The two images here show the power of priming. When you're shown images of a bathroom and hair conditioner, and then shown the letters SO-P, you automatically think of soap. And when you see red, blue, orange, yellow, GR ... you automatically think of green. That's the power of priming.
Frank, I think I actually finally remember our channel intro. Good afternoon. I'm Abe.
Well, let me hold you right there, Abe. We've already reached the end of the video. Unfortunately, I remember the outro. Thank you for watching.
Please like and subscribe.
And comment down below if you have any questions. As always, we'll catch you guys next time.